Spider-Man, Spider-Man, does whatever a spider can. Spins a web any size, catches thieves just like flies. Look out! Here comes Spider-Man.
Oh. Hey, sorry, didn't see you there. You want to come play?
Radioactive blood. Can he swing from a thread? Take a look overhead. Hey there goes Spider-Man.
Pinball is fun and educational. Look at all the fun things you can do with it. You can play pinball while working out. You can even play pinball in the shower.
Oh, this is awkward.
You can enjoy the great outdoors. Pinball even helps you play soccer.
You can even ask to play with neighbors.
Get off my lawn!
Get out of here! With enough skill, you can even play while cooking.
Now you see how fun it is. Let's talk about the physics aspects of it. As you see, the flippers on the pinball machine are actually simple machines called levers. They rotate around what's called a fulcrum. As you can see, the pinball machine is an inclined plane. So it would take less work to push something up to the top because it's an inclined plane than it would be to lift something up to the same height. The pinball machine demonstrates Newton's first law of motion. The ball stays in motion until acted on by an outside force. In this case, the outside force is the sides, the flippers, and these little light thingies right here. Our pinball machine also demonstrates Newton's second law of motion. Acceleration equals force divided by mass. When I put a little force on the launcher, there's a little acceleration. When I put a greater force on the launcher, greater acceleration. You see, when the ball bounces off the sides, it demonstrates Newton's third law of motion. For every action, there is an equal and opposite reaction. When the ball hits the side, the wall exerts an equal and opposite force as the force exerted by the ball on the wall. Since the side is stationary, the ball moves away in the opposite direction to the force. The pinball machine is also an example of projectile motion. As we launch the ball up with the launcher, the ball goes up and then falls back down. It would follow the path of projectile if not for the obstacles in the way. When the pinball machine is turned face up like this, we can see the effects of gravity. What goes up must come down. The launcher is also an example of a spring. This is where Hooke's law comes into play. Hooke's law says that the amount of stretch of a spring is directly proportional to the amount of force applied to it. Little force, little stretch, greater force, greater stretch. It's good. This pinball machine is a great example of potential energy. When I pull back on the launcher or the spring and stretch the spring, the pinball now has elastic potential energy. The more I pull back on it, the more potential energy it has. When I release it, the potential energy is transferred into kinetic energy. The pinball is a great demonstration of velocity. Velocity is distance over time in a certain direction. Whenever the ball changes its speed or direction, its velocity also changes. Now you're having fun and you're learning. So here's what we learned today. Pinball machine. Physics, fun. Physics is fun.
Spider-Man, Spider-Man, does whatever a spider can. Spins a web any size.